So now the activity time is there, and you have to collect some items so that we will use these items that you collected to just generate your model, which you will be training. So you will be able to train your model with the items collected. So yeah, so these are the items that you have to collect. You can just take pictures of any of the items that you have present in your home, but these are the things that will be good. So background is important. Background means the place without that object that you have with you. So just remove the object and just take the background as image. So what happens is when we will train the model, we will also say that okay, this is background. So if the background is visible, no object is present there. So in that case, the model will not take that background as one object, or it will not detect any ghost object, right? These are the things which you can just arrange, and we have collected the data. That is one important thing that we did, and at the end we will train. So where were we? Where were we again? Where we were at what is neural network? So what is neural network? So I will just try to explain this in a very simple way, and it will be mathematical way totally. So it will be fun. You will just enjoy this thing. So let's just take an example of very basic neural network, which is perceptron. So just ignore everything. Just try to hear it as a story, and then you will be able to understand how the neural network works. So forget everything. We will start with a basic. So output is going to meet. Okay, so output is going to meet, and these are the factors which will decide that if you are going to meet or not. And this is the output. Like if you are going to meet or not, it will just tell you that okay, should you go, should you not go. So let's take the factors as closeness of friend. So if a friend is very close to you, then you will just go to meet that person. But if the friend is not much closer to you, then you will avoid meeting him. And then second factor is weather that day. So if the weather is very uh, bad, like if it is raining very heavily, or it is a very heat, very hot day, then definitely you will skip it. But if the weather is pleasant, then you will go to visit that friend, right? That is the second factor. And the third factor is work at office. So if you have a lot of work at office, then you will not be able to meet that friend because you have to work, right? But if the work is not there, then definitely you can try to like meet that friend. Again, these factors are dependent on each other in some way. So let's suppose if the work is too much at office, and howsoever whatever the closeness of friend is, you will not go to meet that friend. And the second thing is, if the friend is very close to you, if he came from like foreign country, or like from a very far place just to meet you, it's fine if the weather is rainy or anything. You will just try anything to meet that friend. If the work is at office is very high, then also you will try to arrange and make some jugaad just to meet this friend, right? If the weather is very nice and the friend is not too close, then also you will just try to meet him because the weather is good and you want to go out and meet that person. So these factors are independent. So closeness of friend is not determining how the weather of that day will be, and closeness of friend will not depend on the work at office. These are the independent factors, but eventually these all three will combine to give you the output that you are going to meet that person or not. So let's assign a weightage to each of the factor. So let's suppose for me personally, the closeness of friend is zero point 0.5. The level it will affect me is zero point 0.5. The weather of that day is zero point 0.2, and then the work at office is zero point 0.8. So these are my personal factors. It will depend day to day. right? It will depend on person to person. So for me, closeness of friend is 0.5, whether that day is 0.2, and work at office is 0.8 because office is important. So I will give the most weightage to work at office and closeness of friend to second thing, and third thing is weather, because definitely I will be going via car or a personal vehicle or via metro. So weather does not like depend. Um, Weather does not affect too much, right? So these are the weights of neural network which I assign to all the factors, and these are the inputs. These are the inputs that I have to provide, and this is how the neural network is. So we have certain features, we have certain weights, and based on weights we find the output. So what we do is we multiply the closeness of friend with the factor, we multiply the weather that day to a factor, and we multiply the work at office to this factor and add them and put it here, and then we will have a certain threshold that okay, if the result is more than zero point 0.5 then I will go, if the result is less than zero point 0.5 I will skip that meeting. And for each of the inputs x1, x2 and x3 we will try to make it between 1 to 10. 1 to 10 why? We will just make it 1 to 10 just as a proper range. So if a closeness of friend, if the friend is very close, I will just make it make it just 9 or 10. If the friend is not very close, he is a very like friend of friend, right? We are not much close, so I will just take it as 1 or 2. And then weather that day is again, if it is very bad day, then I will take it as 1. If the weather is very cool, windy and a little of rainy, then I'll definitely rate it as 10. If the work at office is very low, then I will rate it as 10. If the work is very high, then I will rate it as 1. Like the work pressure is at one level, right? It's not much pleasant, so it's just 1. And all these factors will get multiplied with the weights, and we will give you an output, and that output will decide whether you are going to meet that person or not. So I hope this till this it will be it may be clear, right? So this is a single layer neural network. This is perceptron. Let's move to a little complex one. Again, the output is going to meet, and the inputs are same. So closeness of friend, weather that day, some more input, and work at office. So as you can see, there are more inputs, so I have to create one more input for that. So I will just add mood level to that input. Again, all these values will vary from 1 to 10, and every value or every input will have some weight. As already earlier it was there, now also the weight is there, 0.5, 0.2, 0.8 and 0.8. But now you can see that there are, instead of directly connecting to this one single thing, there are multiple things that are present there. So these are called the layers. So this is layer 1, layer 2, and this is the final layer, right? So these are the layers in a neural network. So what happens is, in this one there will be different set of parameters, and the all the inputs will just combine and will tell you the output of this one. And again, all the values will combine and will give output to certain this layer, and all the value again will combine and give some value to this. And then all these three values will combine and will provide some value to this point. All these three will combine and give again to this, and same for this and this. And finally all these values which will be calculated here will just go and provide the output here. So again it will be the sum of that. And since you can see that there are multiple connections for all of them, then we should have weights for each of them. So ideally, like if I try to just explain it why we are doing this, it's just that okay, so for one factor the closeness of friend is 0.5, but for other factor it may be 0.2, because there will be certain different arrangement of all the things. So I will just have different points and different values, and like let's suppose this one will be of summer, this will be of winter, and this will be of rainy. So all these three things, so summer, maybe the work is low and mood level is different and whether the day and closeness is different. In winter season, the things will be different, but it will be all the parameters of the winter season. And then the third is rainy, so all the parameters in rainy season will be here. And all these parameters again will be combined and will be uh, dropped to this particular neuron, and it will just provide me the output. So I know it's a little tricky to understand, but just take it as an example that okay, that these output will combine with different parameters here, again with different here, and again with some different parameter here. Then all these three will combine here, here, and here, and then the weightage of all these neurons will be decided to find the output, which is you are going to meet or not. So yeah, we will just understand it more in case of images soon. So each node is capturing the specific feature. So when we have these output, each node will be having a different value. Each node is capturing a separate feature. We will learn later. In images it will be more clear. So what happens with images? So till now we have just rated everything from 1 to 10, 1 to 10. The mood is 1 to 10, work at office is 1 to 10. But what happens with images when images are like our point? So in images we try to extract some features. We will just not directly give the whole image to the model. We just try to extract some features, and using those features we try to create a intermediate representation that is used. So in this cat, when we give the image, it tries to find these three features. These three features will be if a tail is present or not, if the ears are triangle or not, and if the whiskers are present or not. These three things we captured, we just find out from the cat. So in that model, if we just pass the input is the like complete cat image. We just provided that as input. Then all the features just combine to create tail, triangle, ears, and whiskers in these three things. And at these point, we will just add tail and triangle, ears, and whisker with different level of weight to create one new feature, right? And then all these features will be combined to provide us the output that we saw a cat or not. So the input was full cat image, and then we extracted the features as tail, triangle, ears, and whiskers, and then we combined those features. So if tail and ears are dominant, and let's suppose the whiskers, for whisker the weight is 0, so it will not be counted in this one. Only tail and ears will be counted. And in second one, both will be at 0.2, 0.2, 0.2, so all three will be there. So tail, ears, and whiskers is present. In third one, only ears and whiskers are present, and in last one only ears is present because it just made the other two as 0. So only the ears one is present and the output is there. Now we will try to give some weightage to the combined features as well. So if tail and ears are present, we will multiply it with 0.1. If tail, ears, and whiskers are present, we will multiply it with 0.9, and ears and whisker is 0.2, and only ears is again 0.2. So let's just take an example. If tail, ears, and whisker is 10, right? It's 10. So 10 into 0.9 is 9. So we will get 9 here. But if it is 1, so we will get 0.9 only. So there is a difference. If it is 1, then we will get 0.9. There is a difference between 0.9 and 10, right? So that difference will just decide the output. So all these features matter a lot. And if the sum, like we can just write a condition that okay, if the total confidence is greater than 9, we will say we saw a cat, because if the combination is more than 9, we will say it's a cat. So now the thing is how we are extracting the features, right? So to extract the feature, we use CNN, convolutional neural network. We give the image. I will not just go dive deep into it. If required, you can just study more or watch more videos on this. But ideally, I'm just telling the I'm just telling the crux of it. So how it works. So you have the whole image in which there are multiple pixels and everything is there. You just take a small part of that and just pass it through the whole image, and that whole image will get reduced in size because for all these square pixels you are just taking a small pixel in the next output, and again you repeat that same thing, you repeat that, and you in the end you will have very less features, very less extracted features, and then you will have this thing. So what is this? Do we know this? Yes, we know this. It is same like the perceptron that we studied. So closeness of friend, whether that day, work at office, and we just multiply it with some parameters and get the output, right? So it sounds easy, right? The features get extracted. The pooling is reducing the image. So if there is a square box of four values, we just try and find the maximum value and just keep it and ignore all the rest three. So you can see that the four boxes is reduced to one box. That is pooling, because in the end we need less features. So that's an important thing. We just use those features and find the result. So in this case again, if tail and ear is there but whiskers are not present, it is just, for example, if tail and ears is present and it, then it will be looking like more like a dog. If tail, ears and whisker are present, then it will be more like a cat. So just for example, what happens if the dog, if the value of this one is 10, if this value is, let's suppose, 1, if the value is 1, then it will be 0.9. But if the value of this is 10, then it will be 0.1 or 1. And when we sum these two, then the whole value will be almost like 0.2, right? 0.2, 0.3. It will be less than 9. So if it is less than 9, we will say that okay, the dog features are dominant because the cat features are not dominant. Understood? So based on that, we will just find and we will set a threshold that if the value is more than 5, then it is cat. If the value is less than 5, then it is dog, right? So what is inside a neural network? So as you just learned, or as you just saw, that there are some weights, certain weights, and the weights will just get multiplied with the input that we give, and the output will be presented. So this is inside a neural network. Ideally you can just see. So we have a function get result, we have y, which is the output. So we just pass the input x, to it, and it will multiply it with the weights that we just discussed. So after multiplying the weights to that particular input, it will return us y. So like the representation on how the neural networks like just extract the feature. So there are multiple layers, as we saw in neural network diagram, convolution neural network diagram. The first layer is a low level feature, like just extract the low level feature. So what happens is the edges, the curves and everything will be just recorded in the first layer, and then those lines and edges will get combined to form the next layer. As you have learned that okay, the first layer, all the values just go in one neuron and so on. So the second, all these will combine to create these pattern. As you can see that you can look that it looks like a tire, it looks like a rim, and there are multiple things which are there. So these are mid-level features, and then these mid-level features get combined to give you a more clear picture. So here you can see it was not clear, but here it is more clear. It just looks like a headlight or tire or like the rim, right? This is looking like a honeycomb shape, and yeah, so just you can figure these things out. That's how the output works, right? So it looks like a honeycomb thing, and this looks like a flower. So these are the extracted features from that. And after just finding those features, okay, that this is present, this is present, this is present, then definitely it looks like a car. But if all these three are not present, instead this head kind of thing and this honeycomb is present, then it is not a car. So the confidence will drop down. So visualizing feature map, what happens when we visualize what happens in those layers? So it extracts the feature as we have just understood that. So we just give him a image of dog and we try to extract but how the model looks like, right? So in this you can see that this is the whole image. It is just covering the boundaries of that dog, and here you can see that the tongue is visible. So if the tongue is out, then most probably it's a dog. The features are more like a dog, and right, and then the second layer, then third layer. So you can see at the end we are getting some eyes kind of thing, that if eyes are of this shape, then it's more likely a dog. All these features will be used to present the final output. So there is an important topic which confuses a lot of people. So to just clear the confusion, so let's suppose we have a total data set of 1000 images we have in total. So for all the classes we have 1000 images. If we set the batch size to 100, so it will create chunks of 100 images, right? It will create chunks of images. So if we have 10 chunks of images of 1000 images, then definitely we have 10 iteration, like we have to iterate 10 times to complete this full data set, to just go through each data set. Just take it example of you are watching images, you are watching photos in your gallery, and at one point only 100 images can be visible, but you have 1000 images. So how many times you have to scroll? You have to scroll 10 times, next page, next page, next page. So you have to do 10 times to just watch all the images. And once you have just gone through all the 1000 images, that is one epoch, right? So that is one epoch. So if I say um, 5 epochs, I have just completed 5 epochs. That means you have gone through all the images that you have present in your system or laptop or phone 5 times, right? So that is epoch. Iteration is uh, for the whole data, how many times we just went through, like we have to press the next page to just watch all the images. And batch size is the images that fit in our grid at one point of time. So during model training, these parameters are really important. So the more you will train, the more epochs you will train, um, the more the better the model may be. Like I am just saying maybe because if we train it too much, it will get overfitted. That is a topic for next discussion somewhere. Okay, fine. That is a topic for discussion later. But yeah, the more the training epochs, it will take more time because you have to go through the whole data set and train it again and again. Batch size totally depends on the size of your phone screen and the GPU basically. In terms of training, we can say that it depends on the size of your GPU. So if your GPU is of 4 GB, then maybe 16 images at once will be just present there. But if your GPU size is more, then more than that can be just processed at once. So batch size depends on your CPU or system or GPU. And iteration, based on the batch size, you have to decide the iteration number of iterations, and data, the more the better. Now we have understood what the neural network is, how it actually works, how the values or weights just flow in, right? It's definitely no magic. Now you have just understood that. So we have completed the introduction to neural networks.